You see sea monsters in movies, dragon heads, tentacles dragging ships under. But there's something worse down there. Real things. Things that don't need Hollywood. Things that showed up on camera for the first time this year. Things we thought didn't exist until a fishing net came up wrong. 7 types. 7 nightmares. Each one proved the ocean hides what we can TM at handle. Which one scares you most? Let TMMs find out. If you value documented deep-sea biology and ocean science like this, subscribe it to TMs, the best way to support our work. Also comment from which city you TM are hearing this from. This script is researched and factual, using sources from the Schmidt Ocean Institute, published in May 2025, confirming the first ever filmed colossal squid. CNN reporting April 2025 on the doomsday fish with 22 sightings in California over 125 years, and research from the Monterey Bay Aquarium Research Institute in February 2025, capturing black sea devil anglerfish alive at 650 feet for only the second time in history. These are primary expedition reports and peer-reviewed marine biology sources that track actual encounters with creatures most people thought were myths. Now back to the information. Number 1 colossal squid, March 9th, 2025, South Sandwich Islands in the South Atlantic Ocean, research vessel Falkor, operated by Schmidt Ocean Institute, depth 1,968 feet, water temperature 4.67 degrees Celsius. A remotely operated vehicle called Sioux Bastion is scanning the twilight zone when something appears. Transparent body, pearly organs, hooks on 8 arms, 30 centimeters long, 1 foot, a baby. The scientists watching the live feed don't TM believe it. Someone comments on the live stream, "Is that a juvenile colossal squid?" They verify the hooks, the placement, the tentacle structure. Yes. For 100 years since 1925, when 2 arms were pulled from a sperm whale stomach, we TM. The known colossal squid existed, Masonicathethys hamiltoni, 8 adult specimens total, 6 from whale bellies, 2 from fishing nets, 0 alive in their home, until March 9th. The footage streams live on YouTube. Dr. Kat Bolstad from Auckland University of Technology confirms species identification 3 days later. Dr. Tom Lindley from Museum of New Zealand. Te Papa Tongarewa verifies independently. The creature they filmed will grow. Adults reach 23 feet, 1,510 pounds, heaviest invertebrate on the planet. This juvenile measured under 12 inches. The eyes were developing. In adults, eyes reach 10 inches across, bigger than dinner plates, built for total darkness. The hooks on the arms distinguish colossal from giant squid. Giant squid have suckers with teeth. Colossal squid have rotating hooks. 300 total across 8 arms and 2 tentacles. Each hook can swivel, each hook can pierce. The middle of each arm carries the largest hooks. Scientists believe these creatures hunt toothfish at depths exceeding 6,500 feet. The midnight zone. No light penetrates. Colossal squid sense prey through bioluminescence created by other animals. They ambush from below. The hooks grab. The beak crushes. Sperm whales hunt them. Scars on whale skin show circular sucker marks 15 inches wide. Battles in pitch darkness. Whale versus squid at crushing pressure. The colossal squid population remains unknown. They avoid research equipment. Their large eyes detect the lights and sounds of submersibles from hundreds of meters away. This March sighting happened because the juvenile was near the surface, possibly sick or disoriented. Within hours of filming, it likely died. But for those minutes, humanity watched a living ghost. The Schmidt Ocean Institute captured the first confirmed footage exactly 100 years after the species was formally named. Michelle Taylor from University of Essex led the expedition. She called it once in a lifetime. The remotely operated vehicle recorded high-resolution video showing color-changing cells on the mantle, chromatophores. The squid can shift from transparent to red. In deeper water, adults become more opaque as muscles thicken. This juvenile TM's transparency is a survival strategy. Invisible predators in the mesopelagic zone between 600 and 3,000 feet. The discovery matters because it confirms colossal squid behavior patterns scientists could only theorize. They birth live young after internal fertilization. No egg masses. The juveniles disperse immediately into different depth zones. As they grow, they sink deeper. Adults occupy the bathypelagic zone beyond 3,300 feet. Temperature drops to 2 degrees Celsius. Oxygen levels fall. Food becomes scarce. Colossal squid can survive months between meals. Their metabolism slows to near stasis. Ambush predators, still and patient. One whale stomach contained remains of a colossal squid that measured 19 feet based on beak size reconstruction. The whale weighed 60 tons. The squid left scars. That battle happened in darkness. No witness except the whale. Now we have footage of what those giants look like as babies. Transparent, delicate, armed with hooks from birth. Number 2, oarfish. The doomsday fish, August 10th, 2024. La Jolla Cove, California, 12 feet long. Silver body with crimson dorsal fin running the entire length. Kayakers find it floating, dead. 24th oarfish in California since 1901. 2 days later, a magnitude 4.4 earthquake hits Los Angeles, 80 miles away. People remember. They connect. Japan calls it Ryugu no Tsukai, messenger from the sea, dragon god, TM's palace. The legend says oarfish surface before earthquakes. 2011. 20 oarfish wash up on Japanese shores in late 2009 and 2010. March 11th, 2011. Magnitude 9.0 Tohoku earthquake, 19,000 dead. 3 reactors melt at Fukushima. The legend strengthens. Scientists tested it. Researchers reviewed records from November 1928 to March 2011. 392 deep-sea fish appearances, 45 species, 8 species linked to earthquakes in folklore. They found no correlation. Study published 2019 in Bulletin of the Seismological Society of America. No statistical connection between oarfish strandings and seismic events. But the sightings increased. November 6th, 2024. Encinitas, California. 9-foot oarfish. 3rd sighting in California in 3 months. February 9th, 2025. Baja, California. Sur, Mexico. Living oarfish, filmed swimming in shallow water. Vertical posture. Struggling. Tourists record video. The fish beaches itself. A man tries 3 times to guide it back to deeper water. It returns to shore each time. Wound on its face, dying. These are Regalicus glesna, giant oarfish, longest bony fish in the world. Confirmed specimens reach 36 feet, most measure 10 feet. They live between 650 and 3,280 feet deep. Mesopelagic zone, twilight zone. Cold water between 3.25 and 13 degrees Celsius. They feed on zooplankton, filter feeders, no teeth. You could put your hand in their mouth without injury, says Russ Vetter, biologist at NOAA Southwest Fisheries Science Center. They swim vertically, ribbon bodies undulating, silver scales shimmer. The red dorsal fin starts at the head and runs to the tail. It looks like a mane, like a sea dragon. That appearance sparked myths. Sailors saw them. Rare, sick, dying, writhing at the surface. They reported sea serpents. Oarfish became kraken, but they're fragile. When researchers bring them up from depth, decompression shreds internal organs. The few live captures die within hours. Depth adaptations fail at surface pressure. Why do they strand? Ocean conditions change. El Niño, La Niña, temperature shifts, oxygen depletion, disease, parasites, old age. Ben Frabel manages the Scripps Institution Marine Vertebrate Collection. He examined the California specimens. Stomach contents showed recent feeding, no obvious disease, perhaps water temperature anomalies, perhaps currents, perhaps age. The 2024 California sightings coincided with red tide and Santa Ana winds. Strong offshore winds, unusual upwelling patterns, 3 oarfish in 3 months. Ben Frabel says changes in ocean conditions and increased numbers of oarfish off our coast could explain it. Scripps has documented 22 oarfish in California since 1901, 125 years, 22 fish, now 3 in 3 months. The Japanese legend persists. Tectonic movement before earthquakes might affect deep water fish. Electromagnetic changes, pressure shifts in the water column. Oarfish detect disturbances, they surface, they die. Then the earthquake hits, it sounds plausible. The data say no. The 2011 Japan correlation was coincidence. Large numbers of oarfish naturally die annually. Most sink, some drift, a few strand. We notice when they appear before major events. We ignore when they don't emit. Confirmation bias, but the mystery holds. February 2025, the Baja sighting. That oarfish swam at the surface in daylight, never recorded before. Oarfish are nocturnal. They avoid light. This one sought sun. Vertical. Struggling. The man in this video said it looked like it wanted to die in the light. Within hours, it did. Social media exploded. Thousands shared the footage. Memes, predictions, warnings. No earthquake followed. The fish died alone on a beach. Its body went to researchers, tissue samples, genetic analysis, age determination through otolith rings. That data sits in labs now. The oarfish has eyes adapted for dim light, large, forward-facing. It detects bioluminescent prey and predators. Its swim bladder is small, neutral buoyancy maintained through a low-density body structure. Muscles are minimal. It drifts more than swims. Lancet fish eat them. but oarfish have few predators. They taste terrible. Gelatinous flesh. Most predators ignore them. They die naturally. They sink. We see maybe 1%. The rest decompose in darkness. 36 feet of silver ribbon falling through black water. No witness, no photo. The ones we find tell us oceans are changing. Species shifting. Currents altered. The doomsday fish isn't Tmintakti an omen, it Thames a symptom. If you value documented ocean science and rare species research like this, subscribe it. TM's the best way to support our work. Also comment from which city you at TM or are hearing this from. This script is researched and factual, using sources from NPR reporting April 2025 on the first confirmed colossal squid footage. Smithsonian Magazine, February 2025, documenting live oarfish encounters in Mexico, and peer-reviewed studies from the Bulletin of the Seismological Society of America, published 2019 examining correlations between deep-sea fish strandings and earthquakes across 8 decades of Japanese records. These are not internet rumors. These are scientific expedition reports and published research. Now back to the information. Number 3, frilled shark, the living fossil, 80 million years unchanged. Chlamydocelicus anguineus, 6 pairs of frilly gill slits, eel-like body, 300 teeth in 25 rows, backward facing, needle sharp, designed to trap squid, fish, and other sharks in sudden lunges, says Professor Margarita Castro, University of the Algarve, 2017. Portuguese coast, Algarve region, European Union project studying commercial fishing bycatch. Net comes up from 700 meters, 2,296 feet, 1.5 meters long, 5 feet, dark brown, serpentine, mouthful of teeth. The crew doesn't know what they caught. They call researchers. Portuguese Institute for the Sea and Atmosphere confirms. Frilled shark, first recorded in Portugal in decades. The shark dies shortly after. Decompression damage. Specimens have appeared in Japan, Australia, New Zealand. December 2014, Lakes Entrance, Victoria, Australia. Commercial trawler pulls one up. Captain David Gao, ITM, have been at sea for 30 years, and ITM have never seen a shark that looks like that. It was like a large eel, probably 1.5 meters long, and the body was quite different to any other shark ITM'd ever seen. Simon Bugg, Southeast Trawl Fishing Association. CETM's a freaky thing. It has 300 teeth over 25 rows. So once you TM brie in that mouth, you TM brie's not coming out. Good for dentists, but it is a freaky thing. The shark was offered to Commonwealth Scientific and Industrial Research Organization. They declined, already had a specimen. It was sold. No record where frilled sharks live between 500 and 1,000 meters deep. Some range to 1,500 meters, 4,921 feet, cold water, 2 to 6 degrees Celsius, total darkness. They feed on squid primarily, also fish, also other sharks. The protrusible jaws extend forward rapidly. The backward teeth ensure prey cannot escape. Frilled sharks have been described since 1884 by Samuel Garman. They were pulled from fishing nets occasionally, always dead. Never filmed alive until 2004. Japanese researchers captured first video, rare footage. Since then, a handful of recordings exist. The fossil record dates them to the late Cretaceous, 80 million years ago. Dinosaurs still walked. Tyrannosaurus rex hunted. Frilled sharks hunted in oceans. Their body plan hasn't changed. Single dorsal fin, long caudal fin, 6 gill pairs instead of 5. Most sharks have 5. Frilled sharks kept 6. Primitive feature, ancient design. Deep sea gigantism doesn't TMT apply. They grow to 2 meters maximum, 6.5 feet. Females are slightly larger. They reproduce via ovoviviparity. Eggs develop inside the female. Young are born live. Gestation period, 3.5 years, longest of any vertebrate. Females carry embryos for 42 months. This slow reproduction makes them vulnerable. Fishing pressure, climate change, habitat destruction. IUCN lists them as species of least concern, but data is limited. We don't know population numbers. We rarely see them. They avoid us. Their large eyes detect lights from submersibles. They flee before cameras arrive. The few specimens we catch show adaptations for extreme pressure and darkness. Their skeleton is poorly calcified, flexible, low density. Their muscles are weak. They don't chase prey. They ambush, slow metabolism. They can survive weeks without food. Their liver stores oil for buoyancy and energy. Deep sea life is starvation interrupted by feasts. Frilled sharks wait. When a squid passes, they strike. The jaws shoot forward, teeth grab. The squid is swallowed whole. Then weeks of fasting. Scientists compare them to Phoebus, Extinct shark genus from 370 million years ago, Devonian period. Fossils from Morocco show similar teeth, similar jaw structure, similar body shape. CT scans reveal Phoebus hunted like modern frilled sharks, ambushed predators in ancient seas. Evolution found a working design. It kept it 80 million years of success, unchanged. But climate change alters deep oceans. Temperature rises. Oxygen levels fall. Acidification increases. Frilled sharks face pressure their ancestors never encountered. 3.5-year gestation means slow recovery from population decline. If fishing nets take too many, reproduction cannot compensate. The species survives because it TMs rare. It TMs rare because deep oceans are vast and unexplored. We have mapped 27% of the ocean floor. 73% remains uncharted. The Seabed 2030 project aims to finish by 2030. Until then, frilled sharks live in darkness. Unknown numbers, unknown behavior, unknown threats. A living fossil swimming in the void. Number 4, goblin shark. April 2025. San Cristobal, Gran Canaria, Spain. Fishermen, Marcos Hernandez and Ram Santana. Depth, 900 meters, 2,953 feet. Hunting hake and deep water perch. Something appears alongside the boat. Pinkish gray, flabby. Long, flat snout like a blade. Jaws that extend forward. They film it. Mitsukurina ostoni, goblin shark. First confirmed sighting in these waters. The fishermen had no idea what it was. They sent footage to marine biologists. Confirmed within days, goblin sharks are living fossils. Family Mitsukurinidae. Lineage 125 million years old. Early Cretaceous. They look like no other shark. The snout is flattened, elongated, covered with ampullae of Lorenzini, electroreceptors. They sense electric fields from prey. The snout cannot stab or pin. It TMs the sensor array. The jaws are the weapon. Highly protrusible. They shoot forward, slingshot feeding. Scientists filmed it in 2016. Nakaya and colleagues at Okinawa Chirami Aquarium used high-speed cameras. The jaws extend 3.14% of body length in 9 milliseconds. Vacuum suction captures prey. The jaws retract. The goblin shark looks normal again. Until it feeds, it resembles a sand tiger shark with an unusual nose. When it feeds, it becomes nightmare fuel. Goblin sharks reach 3 to 4 meters when mature. 10 to 13 feet. One specimen from 2000 measured 6 meters. 20 feet, weight unknown. They live below 100 meters. 328 feet. Most are found between 365 and 730 meters. 1,200 to 2,400 feet. Bathyal zone. Cold. Dark. Pressure 80 times surface level. They are pink because blood vessels show through translucent skin. No pigmentation. In life, pinkish gray. In death, white. They have small eyes, poor vision. Electroreception and mechanoreception are primary senses. Their skeleton is poorly calcified. Soft, weak muscles. They don't chase. They drift. They wait. Prey swims close. The jaws fire. Captured prey includes midwater fish, cephalopods, crustaceans, Macrouridae, Stomidae, deep-sea species. The goblin shark was first described in 1898 by David Starr, Jordan. Specimen from Sagami Bay, Japan, young male, 107 centimeters, 42 inches. Alan Austin collected it. Kakichi Mitsukuri brought it to Jordan. The genus name honors Mitsukuri. The species name honors Austin. Common name comes from Japanese, Tenguzame, Tengu shark. Tengu are mythical creatures with long noses and red faces. Goblin seemed an appropriate English equivalent. Since 1898, 50 specimens recorded worldwide. Atlantic, Pacific, Indian Ocean. Japan has most. Then New Zealand, South Africa, 2 from Gulf of Mexico, 2 from California, Portugal, France, Senegal, Gulf of Guinea. Distribution is global but sparse. They live in submarine canyons, continental slopes, seamounts, areas with complex topography, deep water near vertical terrain. Why so rare? Population could be larger than we know. They avoid nets. They avoid submersibles. They detect approach and flee. Adult goblin sharks sense danger from hundreds of meters away. They swim deeper, out of range. We only catch juveniles or sick individuals. The 2025 Spain sighting was unusual, shallow for an adult. 900 meters, perhaps hunting, perhaps displaced by currents, perhaps dying. The fishermen watched for several minutes, then it vanished. Goblin sharks are listed as least concern by IUCN, but data is insufficient. We don't know population. We don't TM to know reproduction rates. Males mature at 2.6 to 3.8 meters. Females mature above 4 meters. No pregnant female has been caught. Gestation period unknown. Litter size unknown. Pupping season unknown. We assume ovoviviparity like related sharks, but we don't know. What we know, they're ancient, they're rare, they are adapted to deep pressure, and they can launch their jaws like a harpoon. Everything else is theory. In Japan, they are occasionally eaten, caught as bycatch in deep-sea trawling. The meat is rarely sold. It has little commercial value. One specimen was displayed in Yokohama Aquarium. It survived 1 week, died. Deep-sea sharks cannot adapt to shallow pressure. Their physiology collapses. The goblin shark at Gran Canaria swam away. Lucky. Most encounters end with the shark dying in a net or at the surface. They are too alien for our world. Number 5, black sea devil anglerfish. February 6th, 2025, 2 kilometers off Tenerife Island, Canary Islands. Contact Tenerife research vessel Glaucus, photographer David Jara Bogu. The team is searching for sharks. They find something stranger. Melanocetus johnsoni, humpback anglerfish, black sea devil, swimming vertically near the surface. Sunlight. The first time this species has been filmed alive in daylight. Anglerfish live between 650 and 6,500 feet deep. Twilight zone to midnight zone. This one surfaced, dying. It swam vertically, head up, tail down. Strange behavior, never documented. The team filmed for an hour. The anglerfish died shortly after, but those 60 minutes changed what we know. Melanocetus johnsoni females grow to 7 inches. Males reach 1.1 inches. Extreme sexual dimorphism. Males are parasites. They bite into the female. They fuse. Circulatory systems merge. The male becomes a permanent sperm packet. Multiple males can attach to one female. She controls reproduction. She draws genetic material when she ovulates. The males have no function except reproduction. They have no teeth, no lure, no digestive system, just reproductive organs and blood vessels connecting to the female. This arrangement solves a problem. In the deep ocean, finding a mate is nearly impossible. Darkness, vast distances, low population density. If a male finds a female, he never lets go. He becomes part of her. The species survives through permanent parasitism. The female has a bioluminescent lure, modified dorsal fin ray. Esca contains symbiotic bacteria. Candidatus enter vibrio, escacula. The bacteria produce light, bluish-green glow. The female controls the glow. She can flash it, dim it, turn it off. Prey are attracted. Small fish, crustaceans. They approach the light. The female waits, motionless. When prey is close, she strikes, her jaws open wide. Vacuum suction. Prey is pulled in, teeth hold it. The anglerfish has a distensible stomach. She can swallow prey larger than herself. Food is scarce at depth. When you find food, you eat everything. The February sighting sparked global interest. Social media exploded. Memes, art, poems. The video went viral. Millions of views. People called the anglerfish her. They called her Icarus, swimming toward the sun. They called her a feminist icon, biting males, independent, glowing. One commenter wrote, "I like to think she is a respected old grandmother who has dreamed her entire life of seeing the sunlight and the world above the water. She knows her time is nigh, so she bade farewell to her friends and family and swam up towards the light." The emotional response surprised researchers. Anglerfish are typically monsters in media. Finding Nemo, SpongeBob, Luca, villains, nightmare creatures. But this one, dying in sunlight, became sympathetic. Why was she at the surface? Unknown. Possibly sick, possibly disoriented, possibly old and dying. Deep sea fish sometimes surface when dying. Pressure regulation fails, they drift up. Or she was attacked. A predator drove her shallow. Lancetfish eat anglerfish. Perhaps she escaped injured. Swam up. Couldn't attempt to descend. We don't know. What we know, she was filmed alive. Only the second time ever. First was 2014, Bruce Robison, Monterey Bay. Aquarium Research Institute, remotely operated vehicle in Monterey Canyon, 600 meters depth, 1,968 feet. The anglerfish swam horizontally, lure glowing. That footage showed normal behavior. The Tenerife footage shows death. But it shows color-changing cells. Chromatophores. The anglerfish shifted from black to dark red. Stress response, or temperature regulation, or camouflage attempt. Researchers are still analyzing. Melanocetus johnsoni is one of 5 species in the Melanocetus genus, black sea devils. All 5 live in deep oceans: Atlantic, Indian, Pacific. They are bentopelagic. They swim in the water column but rest on the bottom. They are opportunistic feeders. Whatever drifts by gets eaten. Lanternfish, bristlemouths, small squid, crustaceans. Their metabolism is low. They conserve energy. They don't swim unless necessary. They float, drift, wait. The lure does the hunting, prey comes to them. The bioluminescent bacteria are acquired from the environment. Juveniles have a duct in the esca. Bacteria enter from surrounding water. The bacteria are species-specific. Different anglerfish families host different bacterial species. Melanocytus johnsoni hosts Candidatus enterovibrio escacula exclusively. This bacterium has an extremely reduced genome. It cannot survive outside the anglerfish. Obligate symbiosis. The bacteria need the anglerfish. The anglerfish needs the bacteria. Neither can live alone. This relationship began millions of years ago. The anglerfish family diverged from shallow water relatives. They moved to the deep ocean. Bioluminescence gave them an advantage. Over time, the symbiosis became permanent. The anglerfish that surfaced in Tenerife carried millions of bacteria in her lure. They glowed until she died. Then the light faded. The bacteria died with her. Number 6, blobfish. March 19, 2025. New Zealand, mountains to sea. Conservation Trust announces Fish of the Year winner. Psychrolutes marcitus, blobfish. 1,286 votes. It beat orange roughy by nearly 300 votes. The blobfish was named World TM's ugliest animal in 2013 by Ugly Animal Preservation Society. Now it TM's celebrated Fish of the Year. 5,583 New Zealanders voted. Increase from 1,021 in 2024. Public interest in marine conservation is growing. The blobfish won because people understand now. The ugly photos are decompression damage. At depth, blobfish look normal. Smooth head, broad face, large eyes. At 600 to 1,200 meters, pressure is 60 to 120 times surface level, 1,960 to 3,950 feet. The blobfish body is gelatinous, density slightly less than water. No swim bladder, no skeleton, no muscles. It floats effortlessly above the seafloor. No energy needed. Food is scarce at depth. Conserving energy is survival. The blobfish eats whatever drifts by. Crustaceans, sea urchins, mollusks. It opens its mouth, sucks in prey, swallows, waits for more. It doesn't hunt. It sits. Opportunistic feeding. When a trawling net drags the seafloor, blobfish get caught. Bycatch. As the net rises, pressure drops. The gelatinous body expands, decompresses, the structure collapses. What emerges looks like a sad blob. Pink, droopy, frowning. That image became famous. Memes everywhere. Mr. Blobby, World TM's ugliest animal. But in natural habitat, the blobfish is functional. Pressure holds it together. It looks like a sculpin, fathead, smoothhead blobfish, family Psychrolutidae, 30 species worldwide, deep cold waters. The blobfish can live 130 years, longer than most fish. Reproduction is slow. Females lay up to 100,000 eggs in a single nest. She guards the nest, protects the eggs until they hatch. Parental care is rare in deep-sea fish. Blobfish do it. The eggs are the largest of any marine invertebrate. Each egg is several millimeters across, packed with nutrients. The young hatch as miniature adults, no larval stage. They immediately begin feeding on the seafloor. Growth is slow, maturity takes decades. The blobfish population is unknown. They are rarely seen. Submersibles occasionally film them, usually motionless, sitting on mud, waiting. No predators except humans. We don't eat them. The flesh is gelatinous, acidic, inedible. But trawling kills them. Bottom trawling drags nets across the seafloor, destroys habitat, catches everything. Blobfish are bycatch. They are released, but the decompression is fatal. Even gentle handling doesn't tempt to save them. Bringing them to the surface is death. Conservation status. Data deficient. We don't Tino population size. We don't Tino distribution. We don't know threats beyond trawling. The blobfish won Fish of the Year because people realized the truth. The ugliness is human-caused. At depth, they are fine. We bring them up. We destroy them. We photograph them. We mock them. Then we realize we are the problem. The mountains to sea. Conservation Trust used the contest to raise awareness. Orange Ruffy were leading until the final week. Then radio hosts Sarah Gandy and Paul Flynn from ORFM launched a campaign. Save the underdog. Vote blobfish. Listeners responded. The blobfish won. Conrad Kurta, spokesperson for the trust. Regrettably, when it is pulled up, that sudden decompression causes it to become all disfigured. The blobfish has become a symbol, misunderstood, mocked for appearance, suffering from human activity, but resilient. The species survives despite trawling, despite climate change. Despite us, it sits on the seafloor, waits, eats, reproduces slowly, lives for over a century, unchanged. Number 7, giant isopod. Picture a pillbug, roly-poly, woodlouse, common under logs and rocks. Now picture it the size of a chihuahua, 14 legs, compound eyes with 4,000 facets, able to survive without food for 5 years, Bathynomus giganteus, giant isopod, found in Atlantic, Pacific, Indian Oceans. Depth, 310 to 2,140 meters, 1,018 to 7,020 feet. Bathyal zone, cold water, high pressure. The giant isopod can reach 50 centimeters, 19.7 inches, weight, 1.7 kilograms, 3.7 pounds. Most are smaller, 19 to 36 centimeters, 7.5 to 14.2 inches. Still massive for an isopod. Their terrestrial cousins measure under 2 centimeters, less than an inch. Giant isopods are an example of deep sea gigantism. Cold temperatures, high pressure, low metabolism, long lifespan. These conditions produce larger body sizes. The giant isopod is benthic, lives on the sea floor. Scavenger. It eats dead whales, dead fish, dead squid, anything that sinks. It has a complex mouth, multiple parts. They work together to pierce, shred, disembowel prey. The isopod can eat prey larger than itself. When food is scarce, it waits. One specimen in an aquarium went 5 years without eating. 5 years. It eventually died of starvation rather than accept food. Researchers don't know why. Perhaps the food was wrong. Perhaps the environment was wrong. Perhaps it gave up. Giant isopods can gorge. When a whale carcass lands, they swarm. Dozens of isopods. They eat until they cannot move. Distended bodies, full of whale blubber. Then they rest, digest for months. Whale falls are rare. The isopod must maximize each opportunity. Reproduction is slow. Females develop a marsupium, pouch on underside. Eggs are laid inside. The female carries them until they hatch. Young emerge as manca, miniature adults, 60 millimeters, 2.36 inches, already large compared to other isopods. No larval stage. They immediately begin scavenging. The giant isopod can roll into a ball. Defensive behavior, protects vulnerable underside. The exoskeleton is tough, calcareous, segmented, overlapping plates. The eyes are huge, compound, sensitive to dim light, movement detection. In total darkness, the isopod uses antennae, long sensory organs. They feel the environment, detect vibrations, taste the water, smell organic matter. The giant isopod was first described in 1879 by Alphonse Milne Edwards, specimen collected by Alexander Agassiz from Gulf of Mexico. The discovery excited scientists. At that time, the azoic hypothesis claimed deep oceans were lifeless beyond a few hundred feet. The giant isopod proved otherwise. Life exists in the abyss, large, strange life. Since 1879, 20 species of Bathynomus have been described, 4 in the Atlantic, 15 in the Indo-Pacific, none in both regions. Geographic separation, different species evolved in different oceans. The fossil record shows Bathynomus existed 160 million years ago, Jurassic period. They haven't changed much. Successful body plan. Armored, scavenging, patient. Climate change threatens them. Ocean warming. Acidification, oxygen depletion, deep sea mining. These pressures are new. The giant isopod has survived for 160 million years. But the next century might be different. Bottom trawling destroys habitat. Nets drag across the floor, crush organisms, rip up structure. The isopod population is unknown. They are common in certain areas. Gulf of Mexico, Caribbean, off Japan, off Australia. But counts are incomplete. We see them in submarine videos, gliding across mud, feeding on bait traps, occasionally swimming. Yes, they can swim. They flip onto their backs, use their legs like paddles. Graceful motion, unexpected for an armored scavenger. In 2022, researchers described a new species, Bathynomus yucatanensis, found in a Japanese aquarium. Originally thought to be Bathynomus giganteus. DNA sequencing showed 35 genetic differences. New species, 10 inches long, 5 inches wide, cream-colored, collected from Gulf of Mexico. Depth, 1970 to 2,625 feet. The discovery suggests more species exist, undescribed, hidden in the deep. Genetic analysis of museum specimens might reveal dozens more. Each ocean basin could have unique species, separated by time and geography. The giant isopod is charismatic. People love it. Plush toys, artwork, memes, proposals to make it the U.S. national deep-sea animal. Southern Fried Science website has a petition. Giant isopods are accessible. They look like something familiar. Pill bugs, but giant. Alien, yet recognizable. They bridge shallow and deep. They help people understand the abyss. Education, conservation. The giant isopod plays an important role. It recycles nutrients, breaks down organic matter, prevents buildup of carcasses, feeds on what others cannot. Without scavengers, the deep would fill with death. The giant isopod cleans the abyss. 7 types. 7 extremes: colossal squid with rotating hooks, oarfish ribboning through twilight, frilled sharks frozen in time, goblin sharks launching jaws, anglerfish glowing and fused, blobfish misunderstood and mocked, giant isopods armored and patient. Each one survives where we cannot. Pressure we would implode under, cold that would stop our hearts, darkness we cannot imagine. They have been there for millions of years. We have barely begun to look. In March 2025, we filmed a colossal squid baby for the first time. 100 years since we knew they existed, 10 decades, and we finally saw one alive, 1 foot long. What else is down there? What else have we missed? The ocean covers 71% of Earth. We have explored less than 20%. The rest remains unmapped, unfilmed, unknown. These 7 sea monsters are not the strangest. They are just the ones we found. The ocean keeps its secrets, but it gives us hints. A frilled shark in a net, an anglerfish dying in sunlight, an oarfish warning of nothing. The abyss is not empty. It is full, packed with life we do not understand, life that does not need us, life that fears our lights and our noise and our nets. The deepest point on Earth is the Mariana Trench. Challenger, deep, 36,070 feet, 10,984 meters. Pressure, 1,086 bars, 15,750 pounds per square inch. Temperature, 1 to 4 degrees Celsius. We sent a submersible, 2019, Victor Vescovo, Deep Sea Challenger. He filmed plastic bags and candy wrappers. Even at the bottom of the world, we left garbage. But he also filmed fish, snailfish, amphipods the size of your hand. Life exists everywhere, no matter how extreme, no matter how hostile. If there is water, there is life. The 7 sea monsters teach us that. They adapted, they survived, they thrived. While we stayed on land, they owned the ocean. 300 million years of sharks, 160 million years of isopods, 80 million years of frilled sharks. They were here before us. They will be here after. Unless we destroy them first. Trawling, pollution, climate change, overfishing. We threaten what we do not see. We destroy what we do not understand. The blobfish won Fish of the Year because people finally understood. The ugliness was ours, not theirs. We brought them up. We photographed their corpses. We laughed. Now we see. Now we know. The ocean is not empty. It is not lifeless. It is not ours to ruin. It is home to creatures stranger than fiction, stronger than we imagine, more resilient than we deserve. The colossal squid hunts in darkness. The oarfish shimmers in twilight. The frilled shark waits in the void. The goblin shark drifts with ancient patience. The anglerfish glows with borrowed light. The blobfish sits for a century. The giant isopod marches on 14 legs through the abyss. 7 types, 7 nightmares, 7 wonders, each one real, each one proven, each one waiting in the deep. Which one scares you most?